Dear students, today we are going to discuss about the very first topic of probability of class 12, that is conditional probability. So here you go ahead. Here you can write the definition of conditional probability. If E and F are two events of a random experiment, the probability of happening of E given that F has already happened is denoted by PE given F and defined by P of E given F equal to P of E intersection F upon PF, where PF is non-zero. Here F is known as previous event because it has already happened, and E is known as later event. Okay, so we take an example to illustrate this definition, how this definition can be applied. Let an unbiased die be rolled. E is the event of getting a multiple of 3, that means it will contain 3 and 6, and F is an event of getting an even number, so 2, 4, 6. Therefore, definitely we say in the definition intersection is necessary, so we take E intersection F, which is equal to only one element 6. It is a singleton set containing 6. So if you put it in the formula, we see the answer is coming out to be 1 by 3. So this is the mathematical approach to this question. Now suppose I want to give a more conceptual approach. You can see here E is the later event and F is the previous event. And you see how many output are there in the set F. There are 3 output, 2, 4 and 6. Out of these 3 output, how many are multiple of 3 are there? Only 1, that is 6. So that is why your answer is coming out to be 1 upon 3. That means in conditional probability, the previous event acts as a sample space for the later event. Although mathematically we have to approach in this formula, but as a conception you know that the previous event will always act as a sample space for the later event. So this is the basic concept of conditional probability.
Once we are clear about what is conditional probability, we must know about the properties of conditional probability, which is mentioned in your textbook. So the first property you can see, it is probability of S given F. Naturally S intersection F is F, so this probability is 1. Second property is this one, if A and B are any two events of a sample space and F is an event of S such that PF is non-zero, then the probability of A union B given F equal to probability of A given F plus probability of B given F minus probability of A intersection B given F. And this is coming from the union formula of class 11, if you remember. The third property is the complement formula of class 11. We know that probability of E dash is 1 minus probability of E. But here you can see probability of E dash given F is 1 minus probability of E given F. So these are the 3 properties that are mentioned in your textbook and we are supposed to know them.
So we are going to discuss about exercise 13.1, and here is the first question. Very easy, they have given us PE, PF and P of E intersection F. We can easily find out PE given F and F given E by using the formula. And here you have the solutions that I have done for you. You can look at the solution and I am very sure you can understand the solution. Here we have question number 2. We have to find the value of A given B, and PB is given to us, A intersection B is also given to us, and you can very easily find the value and you can see the solution, just application of the formula. Same thing, question number 3, PA, PB, P of A given B is B given A is given to us, and you have to find these 3. You can see the solution, you can very easily understand. You can very easily understand the solution, this application of the formula. On the third part we have applied the formula of class 11, that you have got the union formula, and PA, PB and P of A intersection B values are on the top. Similarly, question number 4, we have to find A union B, and this is given as slightly differently. You can see twice of PA equal to PB 5 by 13. So how we can find the value? We can find out the value PB 5 by 13, PA value 5 by 26, and A given B is 2 by 5, and we have applied the formula and find the value of P of A intersection B. Why? Here you can open the textbook, then it will be easy. You can see solution of question number 5. I am not showing you the question in the textbook. You can see from the textbook. So this is the solution of question number 5, where they are asking A intersection B, we find out. Then second they are asking P of A given B and P of B given A. Now we move to question number 6. You can see in question number 6, a coin is tossed 3 times, right? If a coin is tossed 3 times, then the sample space I have written on the top, there will be 8 output, like you can see, and then E head on the third toss, so I have taken the output where head is on the third toss, and F heads on the first 2 tosses, where I have taken like this, and E intersection F may only one output will be there, so P of E given F is this value. Secondly, at least 2 heads, so here 2 I have taken. You can see the solution, and I'm sure you can understand it very easily. And third one also, at most 2 tails, so we have taken at most 2 tail, matlab 0 tail, 1 tail and 2 tails. So an F is at least 1 tail, so 2 tail, 1 tail and 3 tails, and then as usual formula. Question number 7 I have not done because exactly same as the 6th one. 8th one, you can see, if a die is thrown 3 times, the sample space may huge output will be there around 216. So I did not write all 216, but what I have done, this event E is, what is the event E? E is 4 appears on the third toss. So the third position is fixed, right, for 4. So for the first 2 position we can have 36 output. So probability of E is 36 by 216, 1 by 6. Similarly, F is 6 and 5 appears respectively on the first 2 tosses. Therefore 1 into 1 into 6. So PF is 6 by 216, 1 by 36. So E intersection F may 654, and probability of E given F may 1 by 216, 6 by 216, hence answer is 1 by 6. Question number 9. There is a situation of clicking photograph, family picture. So possibilities: M for mother, F for father, S for son. So in this way 6 ways they can stand, and E is son is one end and F father in the middle, and you can see the probability has come out to be 1 here. And what is the justification of 1? If the father is standing in the middle, definitely the son has to stand in one of the end. So that is why this probability is coming out to be 1. Question number 10. A black die and a red dice are rolled, and you can see this is the output, because the first I will take as the black die, second number I will take as a red die. And you can see the last row I have interchanged the last and the last but one row intentionally, because in the very first question you can see what is the probability of obtaining a sum greater than 9. So A I have taken probability those output where sum is greater than 9, 10, 11 and 12. F may the black die resulted in 5, therefore the last row will come as it is I have written, and hence the value we got. Similarly, here there is a slight cutting here, and this should not be there, but so find the conditional probability of obtaining a sum 8. So 8. E and F may what you take, given that the red die resulted in the number 4. So here what would happen, you should take those output included within this box. So there are 18 outputs are there, therefore we have the solution. Similarly, question number 11 already they have given. I'm sure if you see the solution you can understand it, because already E, F, G are given to us and you can understand it very easily. A family situation where each child is equally likely to be a boy or a girl, so definitely a sample space will be like this. So it is given to us what is the probability that both are girls. So I have taken EGG. Given that the younger is girl, so this is the situation. And second में that at least one is girl. Okay. So 13 question में this is a MCQ question easy fault. Total number question 1400. And E is selecting a easy question is 800 and multiple choice question is 900. And intersection we have 500. The probability of A given F is coming out to 5 by 9. 14 question में what is given to us? E is the resulted in sum 4 and F is which two numbers are different. That means you have to remove the doublets, and doublets means 1 1 2 2 3 3, those are doublets. So if you remove the doublets, the remaining is 30 outputs will be there. So after 30 you can see the solution and understand it very easily. So this 14 question I have done for you. I'm sure if you have understood the concept, you can surely do the remaining 3 questions. And if you do not get it, you can get back to me. Thanks a lot.